Hi, for the seminar of CHP 110, I chose the topic from quantum chemistry, the photoelectric effect. The photoelectric effect tells us that when light of a certain frequency strikes the surface of a metal, electrons are ejected from the metal. This phenomenon is known as photoelectric effect. A few metals show this effect under the action of visible light, but many more shows it under the action of more energetic ultraviolet light. Cesium, which among the alkali metal has the lowest ionization energy, and that's why it is used in photoelectric cells. For each metal, the certain minimum frequency of incident light is needed to eject electrons. This is known as threshold frequency, which is denoted by mu naught or f naught. A light of a smaller frequency than these cannot eject electron no matter how long it falls on the metal surface. The threshold frequency is different for different metals. The kinetic energy of a ejected electron is independent of the intensity of the incident light but varies linearly with its frequency. The graph of photoelectric current and intensity is shows that the photoelectric current is directly proportional to intensity. The number of ejected electrons from the metal surface depends upon the intensity of the incident radiation. The greater the intensity, the larger is the number of ejected electrons. In photoelectric effect theory, light consists of bundle of energy called photons. The energy of each photon being equal to h mu, where mu is the frequency of the light. When a photon of a light of frequency V0 strikes an electron in a metal, it imparts its entire energy to the electrons. Mu naught is shows threshold frequency, whereas mu is shows frequency of the light. When threshold frequency is greater than frequency of the light, then there is no ejection of the electrons, and in case second, when threshold frequency is lower than frequency of the light, then there is ejection of the electrons. When photon of a light strike a metal surface, some of its energy is consumed to separate the electrons from the metal, and the remaining energy will be imparted to the ejected electron to give the certain velocity u. The kinetic energy is equal to 1 half mu square. In Einstein quantum theory, h mu is equal to phi plus 1 half mu square, where phi is equal to threshold frequency and 1 half mu square is equal to kinetic energy. In the Einstein photoelectric equation, E is equal to work function plus K kinetic energy maximum, where work function is replaced by threshold frequency, which is denoted by phi naught. We know that phi naught is equal to h mu naught, E is equal to h mu, and kinetic energy is equal to half m v naught square. Now we can modify the formula. H mu is equal to h mu naught plus 1 half m v naught square. H mu minus h v naught is equal to 1 half m v square. Take a constant, Planck constant, phi h under bracket phi minus phi naught is equal to 1 half m v square. Also 1 half m phi naught square phi naught e. This is a Einstein photoelectric equation. Thank you.